This is under chapter 6, where our topic is spatial description. As you know, I already mentioned what's the layman's term or the other technical term for spatial description. This time, our topic will cover representation. Representation. So for representation, we are talking about the three-angle representation. So the first one is, we have two types of representation. The first one is the fixed angle, or I will begin with the Euler angle. Then the other type is the fixed angle. So you must be aware the difference between the two representations. When we are talking about representation of the three angles, these are involving of three angles that is subjected to rotations. So let's begin with the Euler. So this is Euler angle. What is this? It is about rotation of the three angles. This is the three angles. You know, in the three-dimension Cartesian, there are three angles involved. The angles that are to be rotated about x and y and z axis respectively. So Euler angle, rotation of the three angle, rotations. So rotation or rotation. Which axis is referred to? About or we'll make it rotation because this is about individual. Rotation of the triangle about the current axis of the body attached frame. So this is body attached frame. So this is the definition. Rotation of the triangles about the current axis of the body attached frame. So rotation of the triangle or rotation of one of the triangles about the current axis of the body attached frame. This is now better. Rotation of one of the three angles. Just insert rotation of one of the three angles about the current axis of the body attached frame. That's the definition of the Euler. How about the fixed angle? This is about the rotation of one of the three angles about rotation of one of the three angles, which is referred to about the axis of the reference frame. So this is their difference. Now this definition quite hard to visualize. We need an illustration. So are you still hearing me? Can you still hear me, everyone?
Yes, Mr.
Okay, let us begin with the Euler angle. So let me carry on. Our first illustration, description using illustration will be the Euler angle. Now let me choose the order of rotation. Z, Y, and the X. So prepare the plot. Let me prepare the plot of this. Where is the arrow? Okay, here. I need to prepare for the plot of the y-axis of the reference frame. I need to turn on this one again. Then here, I need to prepare for the z-axis of the reference frame. And then I need to prepare for the x-axis of the reference frame. So this is the frame A, the reference frame. So this is our X. So this is our X. This is our X-axis here. This is our Y. And this is our Z-axis. And then this is for the reference frame. This is XA, YA, and the ZA. So this is the frame A. Now at rest or normal position of the body attached frame, so I will put here. So I will emphasize another color. What color I will do? Okay, here. Now let me change the color. This is red. That is the XB of the body attached frame. And this is the YB. I will make it shorter, but assuming the same axis, I make it shorter to avoid overlapping. There's no issue on that. This is the YB. And then we have the ZB. That's it. Okay. So this is the frame B. So we have the ZB. And we have the XB and the YB. I will not write because that will be rotated. Now, rotation using the definition of the Euler, rotation of one of the three angles about the current axis of the body attached frame. Current axis of the body attached frame. So our rotation will take place that begins with Z, Y, and followed by the X. The last will be X. So the axis, the current axis we will do is the Z, which is our ZB. The ZB is the axis of the body attached frame. So rotation will take place here. Rotation. So what is that? So there are three angles involved. The angle that is to be rotated about Z, we will have that as alpha. This is alpha. About the y-axis, we will set that one, or we will assign that one as beta, and for the x will be gamma. So this is alpha. Alpha, beta, gamma. So since we begin with the rotation about the z-axis, so this is about z-axis. This is about ZB. I need to avoid lots of text here because there are many graphs that involve here. I have to erase this. Erase. So I will just put here rotation alpha. The angle will be alpha. Do not wonder, I use always clockwise. It is assumed positive, but we can do counterclockwise. So always we begin with positive because it will be easier to analyze, but the same relation if it is negative. Now we rotate alpha. The rigid body of frame B affects the rotation of the XA. It will rotate. This is now our XB. When you rotate the ZB, these are orthogonal, so it will affect the rotation. So with this rotation, our XB was here. On the first rotation, we have now this is now the change, the new position of the XB. We call that one XB prime. So this is affected by the rotation of the alpha. And this is also affected by the rotation alpha. So this is our from YB, this is YB here. It becomes YB prime. Does ZB change its position when you are going to rotate on its own axis? Does it change? Yes or no? You tell me. Is it remain in the same position when you rotate the same axis?
No, will rotate.
It will not affect. So this will be your ZB equals ZB prime. So that's the first. This is now the first rotation. Resulted to rotating the Z axis. Now this is done where it involves alpha. Now the next axis is the Y. Now going back to the definition of the Euler, we are talking about the current axis of the body attached frame. So where is now the current axis of the Y? Because this is our next step to be rotated. Where is the current axis of the Y? Tell me, is it the YB or the YB prime? The current means the present position. Which one?
YB prime.
The YB prime. That is this operation or this performance is Euler. You use the current axis of the body at that frame. So I will insert just a line, not an arrow. This is now our current axis. What happened? I select the wrong one. This should be the one. Okay, this is now the current axis. So this we will rotate this one here. So I will again do clockwise again for the positive value. For the y, you use beta. So this is about beta, angle beta. If you rotate the yb prime, it affects the position of the xb prime and the zb prime when you rotate this. Now, when you rotate yb prime with beta angle, this will move here and also here. Now you see for yourself. I will create another arrow here, but that is the same arrow. Will be here. We'll change color for the different position. This is for another arrow here. Here. Okay. Now this is now the ZB, but on the second rotation. So this is affected by the rotation of the beta. So I use different color. This is beta, and this is also beta. Now this change in position, so your ZB prime, the new position will be ZB double prime. And this is our XB double prime. And our YB prime, since this is the same axis, it will retain to be the same as the YB double prime. So this is class. This is done. The last rotation will take place is the x-axis. So where's the new position? Because Euler is looking into the current position of the body attached frame. So where is now the new position of the x? The current position of the xb. You tell me.
Double prime.
Yes, the xb, very good. The xb double prime. So I will plot. This is the same axis. I will just emphasize different color. And when you rotate the, sorry, why I drew this? I am talking about the axis, not rotating. Correct that one. This will be our current axis of the body attached frame, which is the XB double prime. So with this axis, this will be rotate as the angle gamma. That angle is called gamma. So we'll rotate that one, the gamma. That affects the other axis of the body attached frame, the YB double prime and the ZB double prime. So we will create the new position. Create an arrow, the same arrow with new position. So this is I will use dark. Any other color? I will better use the black one. Okay. So this is now the new position of the ZB, and for the YB here. So That is the last rotation. So therefore, we rotate the gamma. So the other axes are shifted by the position because of the gamma. So I will write now the gamma here. This is the result of the gamma. And this is the result of the gamma. So this is our y, b, triple prime. Since this is the final position of the YB triple prime, this is the last, we treat this one as the YB, as the final. From the previous YB, this is the last YB. And this is our ZB triple prime. Since this is the last rotation that took place, this is our ZB, the final ZB. And also, this one, our XB triple prime, since this is our last, this is our XB. The last position of the XB from the original position. So what you have witnessed or observed or seen, this is the Euler angle representation. Okay, so since we are talking about one set of Euler angle representation that is ZYX, so we'll come up the equation here. Are you still there, everyone? Ladies and gents, just to check. Reply, are you still there?
Yes, sir, we are here.
Okay. We are talking about the triangle rotation, so it's the R, which is to the frame B from the reference. And this involves one set of that Z, Y, X, not Z, X. And this involves angle alpha for the Z and for the Y, which is beta, and for the X will be gamma. And this is under Euler angle. What will be the triangle relation? So we know the R already. So the first rotation that took place was the Z. So R, Z, which is about an angle rotated about, it is about Z axis of angle alpha from the reference to the first rotation, which was the B prime. This is what happened here. Then the next rotation that took place was again R, which is the y-axis with the angle beta. And the previous was B prime, and the current is B double prime. And finally, the last rotation that took place was X. So that was R, X with the gamma. And the last was B double prime, and this is the B triple prime. And since this is the last position, I will not write triple prime, B. That is why you see here B from the reference to the current position of the body attached frame. This is B. That's why it is B. This is the B triple prime. We did here. So from this illustration, we obtain the triangle representation. This is the triangle representation with the three different rotations. So what is the equation here? You are aware already about the rotation, about z-axis. You tell me, what is the R matrix for the z? You tell me, for the z-axis. Anybody? Still
Cosine.
very good. Cosine alpha.
So
This is
minus
minus sine alpha.
alpha.
This is 0. Sine
Cos
alpha.
cosine
Cosine alpha. 0,
0
0, 0,
0
1.
1.
Because this is the z. Then multiply that with the next rotation matrix. This is y beta. So this is cosine beta, 0, sine beta, and this is 0, this is 1, 0, negative sine beta, 0, cosine beta. That's for the y. And finally, for the x gamma, so this is 1, 0, 0. And then this is 0, cosine gamma, minus sine gamma, 0, sine gamma, cosine gamma. So we need to simplify this so that we will have the first set of the triangle representation, which the set is ZYX, Euler. Now, how to simplify this? You work around on the first two matrix. So, how to do that? Vertical here, multiply to the horizontal. That's the rule. Rule of the matrix. Okay. Remove this. Remove this field. That's it. Change color. Yes. That's it. We will multiply the first column of the second matrix. Do not wonder why I'm doing this. It's the rule of the matrix with the horizontal. So that's how you will do. Okay, so there's no need to elaborate. That's we will apply the multiplication of that matrix, the rule for the first two matrix. This is quite long. I think this is quite long. So I have to expand a little here. I will start here. Okay. Cosine beta, multiply this, 0 multiply this, this. So multiply this, we start with the alpha order and cosine beta. Then you have here 0 times this, plus 0, plus 0. That is the first value of the first column, first row. Next, the same, you will do this here. The same, cosine beta times sine alpha. That will be sine alpha, cosine beta. That's what happened here. 0 times this, plus 0, times this, plus 0. Follow carefully, huh? Multiply this to the third row. This is 0,
plus 0
plus 0.
plus sine beta.
That's negative sine beta. We have now the first column. Now go to the next. I will copy this. Now the same process. You will do it here. Change color. Make it green. Okay, that's fine. Multiply this To here, it will take the middle only because the rest will be 0. So in the second column, where is it? It will be 0 minus sine alpha plus 0, 0 plus cosine alpha plus 0, and this is 0. Vertical to horizontal, this is 0. So we are done with the second column. Now we go to the third. The same process, and make it green. So the last one, this will become here. Sine beta, multiply this, we have cosine alpha, sine beta. This to this 0, and this to this 0, plus 0, plus 0. Then this to this, we have here sine alpha, sine beta. 0 times this plus 0, and this 0. This one is 0. This one is 0. And this one we have the cosine beta. Talas, we are done. 1, 2, 3. This is now removed. Then rewrite the last matrix. Just rewrite 1, 0, 0. 0 cosine gamma minus sine gamma. 0 sine gamma cosine gamma. Oh. So we make it this one simpler. Actually, no need to write that one. So this is now cosine alpha. What's this? Cosine alpha, cosine beta, sine alpha, cosine beta, negative sine beta. This is negative sine alpha. Is this, are we sure this is negative? This is not negative. This is, you have to be careful here. One single mistake all. This is the problem with the matrix. And this is 0 here. Then this is cosine alpha, sine beta. This is sine alpha, sine beta, cosine beta. This is 1, 0, 0. 0 cosine gamma, sine gamma. 0 minus sine gamma, cosine gamma. I just repeat, I simplified only that one. It's not an issue on this part. Now the next is you do the same. The same what happened here to the horizontal. So I will not make a box, or I can put the box again. Oh. Over here, and then wait, and let me finish this. And then another one. Okay. Yes. Here, you do it here. Okay. So obviously this is 1, the rest 0. So this will be what happened. Take the values vertical to horizontal.
Cosine
So what
alpha,
you will write
cosine
yes.
beta.
You write here cosine alpha, cosine beta. The rest is 0. Next, you do the same. This is sine alpha, cosine beta. You do the same to the next. And you do the same to the next, you get negative sine beta. Next, this one here, 0. And this is here. So, and this one here. Did you see it? This and this
Yes.
one 0. This and this is negative sine alpha, cosine gamma. And finally, this one. I will write this first because it's positive. Cosine alpha, sine beta, sine gamma, minus sine alpha, cosine gamma. This and this. That's finished. Next, you go to the second. This and this. 0 times this is 0. This one. Cosine alpha, cosine gamma. And this one, plus, it's longer. There is that one, it's long. So that will be cosine alpha, cosine gamma plus this and this, sine alpha, sine beta, sine gamma. This and this plus this and this, we will have only cosine beta, sine gamma. 0 times this is 0. This one is 0. What is left is this one. Finally, we have the third. 0 times this. What we will get? This is negative. Sine alpha, sine gamma, plus this. Plus what? Cosine alpha, sine beta, cosine gamma. Next, this one and this one, 0. And this one, negative. So I will start the next. That will be sine alpha, sine beta, cosine gamma, minus this one and this one. I just reversed, but that's correct. If you start with negative, this one. That will be cosine alpha, sine gamma. Make it clear. And finally, this one here. 0. What is left is cosine beta, cosine gamma. Now, this is now the final equation, final matrix. This is a 3 by 3. This is the final matrix for this. This one. I will box this. This is the final one. So the problem in memorizing this is too complicated. That is why it is important you know how to bring this and get the final answer, because it's too long to memorize this one. So that is why I explain how to get it. So let us see if we match. It was now written here. There was that. ZYX. Okay. So let us check. Cosine alpha, cosine beta, correct? Cosine alpha, cosine beta. I write wrong here. Why I write cosine here? This is a mistake. This must be S. It's only typographical error. Sine alpha, cosine beta, correct. Minus sine beta, correct. Cosine beta, sine gamma, correct. Cosine beta, cosine gamma. Now these 4x are the values of this. This is One x, another x, another x, another x. By the way, this is beta. So this is now the formula how you will get. So this is an example of the Euler. The same you will do for the other another sets. There are several sets on that. Okay, how many sets you can count? We have one set already. That is Euler, Euler, angle sets. What are those? We have already started with Z, Y, X. What can be another possible set we can make? Tell me.
Z prime, Y prime, X prime.
We are talking about the rotation of the axis. This Z prime, Y prime, X prime
You
is about
definitely
Euler.
use it.
No, you are going to rotate Z, then followed by X, Y. This is another set. What else? You are talking about this. It's Euler. Another way to show Euler. Z prime, Y prime, X prime. It represents Euler. Now tell me, what are other sets we can have rotations?
X, Y, Z.
Yes, we have the X, Y, Z. What else?
Y, X.
Y, X, Z. What else? Anybody?
X, Z, Y.
X, Z, Y. What else?
Y, Z, X.
Y, Z, X. What else? No more?
No more, Mr.
There is. I will start with Y, then followed by Z. Then you will do Y again because that Y is already in different position after you rotate Z, right? Next, we have Z, Y, Z. You started with Z, then you rotate with Y, then you can do it again because the Z, after Y, the Z was different position. Next, anybody, give me another.
XZX.
Correct. X, Z, X. How many? What else?
X, Y, X.
X,
Y,
Y,
X.
X. There are two more.
ZXZ.
Z, X, Z. What else? There's one more.
Y, X, Y.
Y, X, Y. Okay. Y, X, Y. Oh. This is now Y, X, Y. So you can see there are 12 sets. Okay, we are done with this. This is Kalas. Okay, we are done with the Euler. Now we go to the fix. For the fixed angle, by the way, let me go back here. Normally, alpha, beta, gamma is given. For example, 5 degrees minus 10 minus 20. If you don't memorize, you build up this with the values. Then with the values, do not derive anymore. Values you will put here because you have alpha, beta, gamma values. Get the values, then start doing this process. And you will arrive the values of this. if you have the values of the angle. 3 by 3. It's 3 by 3. So let us go to the fixed angle representation. For the fixed angle, I will choose X, Y, Z for the fixed angle. So this is the X, Y, Z. So I will prepare the graph. Okay, this is now for you. Watch carefully the difference between Euler and the fixed. So this is the reference frame YA. And this is the reference frame ZA. And this is the reference frame XA. Now, for the frame B, this is the XB. Change color. Make it red. What's the red color? Look. And then we have for the YB. And then we have the ZB. Okay. For the fixed angle, this is our XA. This is our XB. Start with the XA. Then this is our YA. And this is our ZA. Now for this is ZB. XB. And this is our YB. Okay. We have here the rotation. Again, we use the same angle. For the Z axis, for the X will be gamma, beta for the Y, and alpha. Okay. Now, this is the erased. This is erased by the way. Rotation about the X-axis. This is the first rotation that takes place, X-axis. So what will happen? So go back to the definition of the fixed angle. Rotation of one of the three angles. One of the three angles, okay. About the axis of the reference frame. We use the reference frame here. Axis of the reference frame. So go down. Okay. Now start with the X. So we will have the X to be the reference. This is the reference, the first. So when you rotate this one about XA, not X, this is deleted. Not XB, XA, because fixed is looking into the reference axis. So XA at what angle? At an angle gamma. So this will be gamma. When we rotate that one, we use the positive direction. Your XB remains XB double prime. I mean the first prime. We are looking on the first prime. And when we rotate for the XA, your YB will be affected. So I will create another arrow here. This is now the result of rotation. Change color. Then what else? I use orange here and here. Okay. So this is now the gamma, and this is gamma. That's the ZB prime here. This is now the ZB prime, and this is our YB prime. So X is done. Our X is done. Next is the Y. So which axis we will use to rotate? Is it the, can you tell me which axis? Because we are now in the Y. Is it YB prime or YA? That
YB
is
prime.
not YB prime. If you look at the YB prime, it's Euler. This is fixed. You use reference here. That's the difference here. Huh? If you are thinking the YB prime, that's Euler. We think of the fix. So rotate in a positive direction of the angle. This is beta. When you rotate the beta, you will notice that the XB prime, YB prime, and ZB prime will all rotate. They are 90 degrees with each other. They will all rotate. So look at carefully, new arrow, same arrow. I will just put it here. I will make color blue or different color. Make it green. Yes. So this is now the XB double prime. XB double prime. This is affected by the beta. And the other one, this is also affected by the beta when it is, this axis is affected. So this is green. This is beta. This is now YB double prime. And then this ZB is also affected. This is green. So this is affected by the beta. This is our ZB double prime. That's it. The next is the Z axis. This is all then not alpha. The Z axis, since this is fixed, the axis of rotation will be the ZA. I mean ZB. That's not the reference. This is the fix, the difference between Euler and the fix. This is now alpha. We rotate the ZA. So all the three angles, the current was green. You notice same axis, the reference frame. So here, I will use black here. This is now the, yes, this is resolved by the alpha. That's alpha. And this is your XB triple prime, which is the last. And how about for the other one? The other two here is also affected. So here, make it black. This is our alpha. This is our YB. Triple prime equals YB. And we have the last one here. This is the ZB triple prime. Equals ZB. This is affected by the beta. You notice that for the reference, this is now the result of the fixed angle using reference. It is called fixed because the axis of rotation is using the reference frame. This is the XA, YA, and the ZA. So we have the graph of the fixed. Now how to obtain the now this is about the rotation B to A for the X, Y, Z with the angle. With what angle is that? The angle will be, for the X is gamma, beta, and alpha for the Z. This is fixed. Now what is the rule here? What is the rule? The rule is the R, B, the rule is rotation. For the fixed, when you are going to determine the equation of the fixed, the first here will be the last. The last will be the first. So you will notice that R, Z, alpha will be the first times. What's this? For next is Y, R, Y, beta for the second. Times the last, the first will be the last. So X, R, X, and this is gamma. Don't forget, if you deal on fixed, if you deal in fixed, the first will be the last in the matrix multiplication. And the last will be the first. That is why, take note that the R, X, Y, Z, alpha, gamma, beta, alpha, fixed. So this is the equation. B to A, this is B to A. You will notice that this one equals R, Z, Y, X, B to A. What? Alpha, beta, gamma, Euler. So I will box this one. This is there. Or you may emphasize R, V to A, Z prime, Y prime, X prime, alpha, beta, gamma. That's represented by Euler. So whatever you did here will be the same equation you will get, which is this one. So there is an exact opposite of the Euler between Euler and the fix. Where is that equation? The last one. The last one. Here. You will arrive this equation. I will just take the screenshot. Here. So this is the equation between Euler and the fix. You are aware that x, y, z of the fix equals z, y, x of the Euler. And this is the equation you will have. So what are the sets of this? There are 12 sets of the fix. You tell me. Fixed angle sets. Start with the x, y, z. We solve the x, y, z. Then we have the x, z, y. And here we have the x. Any other no change. This is y, z, x. What else? X, y. We have already x, z, y. We have. So that will be y, x, z. What else? In the, we have x, z, y. No, we have x, z, x, y, z. Yes, we have already. So z, x, y. What else? X. What else? One more to complete. What is missing? Z, x, y. X, z, y. We have y, x, z. Y, x, z. Yes. It's already here. What is missing? One more.
ZYX.
Okay, let me check. Z, Y. Yes. And the rest will be X, Y, X. So here, this will be, the angle will be gamma, beta, gamma again. Gamma 1 or gamma again. So X, and this is Z, X, X, no? This is Y, Z, Y. This is Z, Y, Z. There are two more. X in the middle. Y, X, Y. What else?
ZXZ.
Okay, Z, X, Z.